Welcome to Everything Distributed. Today, we are going to talk about a new type of computation paradigm called edge computing. And the material is based on these two very articles. One is the project page by Microsoft. They introduce what they have done in edge computing. And then the next one is an introduction on edge computing by Cloudfare. So what is edge computing? And then the idea is actually pretty simple. It's that you move the concept of cloud closer to the user or closer to the data. Okay. Then the reason that we want to do this is that usually the data or the computation is too large right now. If you always need to send something into the central, like one big data center, then it's likely that you will need to consume that on network bandwidth and then the latency, the delay because of network message delay, that is sometimes too large for your application. So you want to move something, this computation data closer so that we don't need to suffer this kind of latency. And then the history is that we have cloud, and then later on that people propose this idea, said that the cloud is too expensive. We cannot have too many of them. So why don't we have a concept of micro data center, which is called clouded? And then we kind of take it to the extreme so that we have edge server, Fox server, or like Mist server. So the concept is that we might have a very, very small data center or even just like some computational data storage resource, but that we have many of them, and then they are surrounding us, just like the fog or mist, and then that can be used to support the fundamental data storage and computation that we need. And on a very high level, you can think about edge computing as a kind of the harmony marriage between all many different or between all this research area. We have original cloud computing, we have mobile computing. How do we do the all kind of a computation application on top of your mobile phones? And of course, we still need to have network because that's the foundation on like how can we exchange message, exchange data, and then we also have the application. So it's a very, very exciting area. And then from that if you want to look at more closely, if you think about it, it's a very huge change of the model. And I call it as a kind of computation paradigm shift. So initially, everyone has a personal computer, and then that's kind of local, very personal computation. For example, all the softwares installed on your own machine. And then later on, we have this concept of a peer-to-peer or even a voluntary computation. And it's like kind of a decentralized case. And then the idea is that a personal computer, you cannot have everything. So suppose I need to search all the movie files. I want to search all the different like kind of ebooks or those things and all the music files, then my computer doesn't have enough storage to save all of them. So we kind of need to collaborate with others, and then that's the concept or the motivation for the peer-to-peer file sharing. Some of the well-known software like BitTorrent, Emu, Napster, and then actually the early version of Skype, they also use this peer-to-peer paradigm to support voice on internet protocol, so VoIP. And then that's how they can support tons of different phone call over the internet. And of course, that later they find out that there's a certain limitation, for example, maybe privacy, security, or bandwidth consumption. So they shift it to the more typical cloud computing paradigm. And then right now, the cryptocurrency is very hot because there they want to have a less regulation, and then they want to have a very high involvement participation. So the concept of peer-to-peer still very important there in terms of like Bitcoin and Ethereum. Of course, there are also other type of cryptocurrency and other type of blockchain, which we might talk about next. And then the next one is that people find out that if we only look at peer-to-peer or that only a personal computer, we cannot deal with the concept of big data. And then the data size might be in terabyte or petabyte. It's basically huge. You can never process that kind of data on coordinated machines. So now people say that, okay, why don't we have a huge data center that's in a centralized, very well management, and then we are always dealing with large scale. And that actually is the backbone of the modern kind of website or modern internet. For example, you look at Facebook, Instagram, or like WhatsApp, or like all those social application, or even like bank, like there are tons of data, and then we can only process, analyze those data in the big data center. And then, for example, Gmail, Dropbox, and then there are tons of advancement on like how to deal with those big data. And these are all in the category of cloud computing. And then finally, we get to the point for today, which is edge computing. So in a sense, it's you can think about it has all the elements, because the concept is that you have a one big data center. And in fact, that you may have multiple of them if you want to do geo-replication, but suppose let's have one. And then you also have some smaller one, let's call it the edge servers, or that it can be the concept of micro data center, cloudlet. And then later on, we have users or like edge device, and then the smaller one. And then here, you exchange data or computation locally with like a close by edge server. So that's the concept of bringing the cloud closer to users. And of course, there's still some coordination between data centers and then edge servers. So that edge computing kind of catch-all concept. You have the centralized server here at the cloud computing, and then you have a decentralized layer that the ES, or that if you want to look at it, is that this kind of a group because users will talk to the local edge servers. And of course, because of some privacy or security issue, that each users, you also want to do some kind of computation locally. Okay. So that's the big picture for edge computing. Then the next question you want to ask is that, what are some of the applications that fits in the paradigm for edge computing, but not for others? And like one thing that everyone want to sell is that AR and VR service, because the data amount is huge, and then you need super high bandwidth. And suppose you want to watch something on your phone, basically right now the model is not really sustainable. Then so you want to kind of collaborate with a local edge server that provide enough data storage or like network bandwidth or computation, so that you can really enjoy what's inside AR VR. And then the next one is like Internet of Things, or even like smart city. Because of the device, if you look at this, maybe one sensor node or one Raspberry Pi, it's very small, and then it has limited energy. So if it wants to store something, like analyze something, it should like collaborate with a local edge server to get the data or get the analytic done. And of course, I will also have an autonomous vehicle. I need to share data, collaborate with others, and drones. And then one new thing about this, or one not necessarily new, but a very hot thing, is that how do we do machine learning and federated learning in this paradigm? And ideally, you want to do all the training on your phones or on your smartwatch, because that's only use your personal data, the data you don't want to share with others. But sometimes but most of the time, those phones are not powerful enough to train a complicated model. So what would be a good way to train the model without like losing too much privacy? That's a very active research area. And yeah, the architecture here is very similar to the one I draw. So basically you have one big data center and then some like you have like smaller edge servers and you have edge devices. And then there you have a different way to communicate with each other. And then if you want to kind of have a long range communication, you will use like 4G or even 5G. But like if it's between the edge servers and then cloud data center, you might have a specialized fiber to come to have a more efficient communication. And then when it comes to edge server, edge devices, and the edge server, the communication between them, those are kind of those different wireless communication. Okay. Then, so what exactly is edge server, edge device? Unfortunately, there's no kind of de facto definition. So it's kind of something that anything that is close to the user, and then it can do certain type of storage or certain type of computation, or even just a certain type of communication capability. For example, you have a sensor device, your router, your roadside unit to serve the cars, and then a cell tower base station that's a foundation for 5G service, and then your personal computation machines, your camera, phones, watches. Those can be in some can be considered as edge devices, and if some of them are in a more powerful domain, they could even be edge servers. Okay, so that when I try to understand this, you shouldn't limit to yourself that, oh, there's a universal definition of like how the thing should behave. Instead, you should look at this architecture and then think about that, okay, what would be the benefit for this kind of hierarchical design? And then what can we do here? Okay. And then in terms of research or in terms of real deployment, there are tons of open problems. And then the basic thing I talk about storage and then for computation. And one big thing about this domain is a test offloading. So for example, if you want to play a game on my mobile phones, but like it need to render that kind of your graphics, you need to maybe like the real-time training the AI for the computer player or something, then oftentimes your phone is not powerful enough. So you need to ask the help from the edge server, say that, hey, can you do this computation for me? And then that's a test offloading, because how to do that, how to do it safely, how to do it efficiently, all open problems. And of course, we have a security, privacy, reliability issue. And then when we have something, we always want to push it to the limit. We have performance issue. And then in terms of hardware, then what would be the infrastructure? What's the communication protocol? How do I design an antenna? And one big limitation for 5G, that this I have millimeter wave thing, is that the antenna is actually unidirectional. So one on the positive side is very good. There's very few interference, but then it also cause some big problem technically, because you need to decide who the receiver is. Okay. And then of course, if you want to build the real applications, and then there are it's not clear like what would be the programming model, and then what's the kind of the framework or the pattern to develop this kind of application. And then many of the edge devices are small, so like power efficiency is also important. And then one big thing that's different is that all the edge devices, they are mobile, they can move around, and then how to handle this mobility. And then in terms of deployment, where should I place this edge server, and then how do they communicate with the cloud? That's all different. That's yeah, that's all like open and exciting research area. And for example, like you can check the link. Microsoft has done a lot of research, and then I think that it gives you a very good overview or introduction on like what are some of the research or the new problems they are looking at. And I think that it's very inspiring if you are into this area. Okay, that's all I want to talk about today. The takeaway is that I want you to know that what's edge computing, why do we care about it, what's the benefit, how is it different from the traditional concept of cloud computing, and what are some of the applications, and what are some of the exciting research directions. Okay, that's all. Thank you.